presentations within that session out of the roaming business, and our first speaker of the afternoon is Stefan Winter. Stefan Winter is working for the NREN in Luxembourg as a research engineer, and Stefan will tell you all about RADSEC. For those of you who are not familiar with RADSEC, it's supposed to be a secure solution of a protocol called Radius, and he will fill you in with all the details. So Stefan, the floor is yours.
Good afternoon, ladies and gentlemen. Thanks for coming. My name is Stefan Winter of Vestena. I did this presentation together with Stig Bernars from Uninet in Norway. And as you can see, the title is a protocol called RADSEC, which is basically a synonym for the Eduroam people are messing around with Radius. And I would like to explain you what we are doing with Radius and why we are doing it. So the first question we are going to answer is, well, if we mess around with it, what is wrong with Radius in the first place? And then the next question is, well, what is RADSEC? Is this in any way a standard, or will it become some? And if you like to play with it, how do you deploy it, and how did we deploy it in Eduroam, or how are we going to deploy it in Eduroam? So the first question, what's wrong with Radius? Actually, I don't have to say a lot about this topic, because in last year's TNC we had an excellent presentation by Josh Howlett, who identified several shortcomings in the infrastructure as we have it now. I just picked two random examples of what he said, and he was very right with saying this. One thing is, Eduroam relies on technologies that weren't designed for what Eduroam is trying to do. Well, those of you familiar with Eduroam may know that we are using Radius proxies a lot in the international context to broker around between institutions and between countries. Unfortunately, the operation of a proxy is exactly what the Radius specification was very silent about. There's not more than a few sentences about Radius proxying. So yes, we use it, yes, it works, but it was not entirely thought through back in the time, which is a bit dangerous in itself. Another sentence he said is that the authentication that's happening is slow and fragile over a lossy network. When he said that, I was a bit skeptical, sitting in the audience myself, and thought, well, it's not that bad after all, it works. Meanwhile, this year has passed, and we have a monitoring infrastructure for Eduroam, and what we are seeing is that typically an international authentication takes about 2 seconds to actually be done, which in the networking world qualifies as being slow, I suppose. Yeah. The other thing, it's fragile over a lossy network. At some point I sat down and thought this sentence over, and I did a little calculation. It's not that complicated. Please follow me if you can. The first thing is, when you authenticate with a tunneled EAP method, there is not just one packet going back and forth, there is a conversation going on in the EAP exchange. Typically it takes 8 Radius round trips to do the actual authentication, because so much data about certificates is being exchanged. Which means when it's 8 round trips, there are altogether 16 different packets from one end to the other. Since we have 3 to 4 proxies in the middle in an international roaming context, this means that there are altogether 5 times 16 Radius hops to traverse with those messages. Now comes an estimation. I estimated that these Radius hops have a distance in IP of about 5 hops to each other. So altogether we have 400 IP packets in flight for doing an authentication in the international context. Yet another estimation, I was assuming, let's say, routers maybe lose 1 in 100,000 packets, which is quite a good thing in principle. But well, we have to rely on this working 400 times in a row for people to authenticate without a significant delay, or even failing at all. Because as soon as a Radius server doesn't get the response it wants, it waits for something like 5 seconds, and well, this adds significantly to the delay. Or maybe the supplicant just gives up because it takes him too long to authenticate. So if one packet gets lost, we are already in some kind of trouble. And well, a bit of probability looking into this means that the probability of successfully authenticating on such a network that loses 1 in 100,000 packets is at 99.6%, which sounds maybe nice. But said the other way around, it also means that 1 in about 250 is going to fail for no specific reason, because something is broken on the servers or something. No, it's just because the internet is like it is, and at times if a packet gets lost, you have a problem. This is not as theoretical as you might think. Actually, you are experiencing it right now, right here. The last days in the conference at some point had a link that was overloaded, among other problems. But yeah, some authentication packets just got lost. And if you have been wondering why you had to authenticate 5 times in a row, and then all of a sudden it worked once, this is one of the possible reasons you could have for this. In this case, it was just one IP hop, but the probability of losing a packet was significantly higher. So that compensates for all the other perfect IP hops in the Gen2 network behind that. So that is some kind of a shortcoming. But there is more. These are some of the classics we had ever since at Rome, and basically in everybody who is using radios. Most of the packet content is actually in clear text. There is very little encryption going on. There is a bit of packet integrity check, and if you have a password in there, the password is encrypted. We don't even have a password in Rome because we have those tunneled EIP methods. But still, there are things on the wire like the MAC address of the user who is trying to authenticate. You could maybe guess about his approximate whereabouts if the NAS IP address is a public IP address that you can look up where it belongs to. Also, you can always see the home domain of the user. So you're getting a pretty good picture of who is trying to authenticate just by listening to the traffic. These are all, well, let's say, soft things you learn about the user. You don't necessarily learn the username if the user paid good attention to use an anonymous identity, but you can if you forgot to. So that was a bit uneasy. And this was, by the way, one of the most compelling reasons for us not to put any sensitive data about users on the wire, like describing his role as professor or something. If the user happens to forget obscuring his outer identity, an intermediate could learn a lot from the packet. So that's why we said authorization attributes shouldn't belong in a packet that just floats around the internet, mostly unencrypted. Another thing we also have since the very beginning is we have so many institutions connected that we cannot build a mesh of all of them directly authenticating. We have literally hundreds and I think over 1,000 actually institutions, and that would mean as soon as a new institution comes along, we would have to modify the configurations of all others. That was seen as not scaling for obvious reasons, and so we had to produce this hierarchy to connect servers. The underlying reason for that is that Radius has to know the IP address and the shared secret with the peer it is going to talk to. So there is only a very static possibility of hooking Radius servers together. And another also quite an easy thing about Radius is it is based on UDP, and there is no idea about is a server alive or not, because there is no TCP state to maintain where you would see the connection is actually there. So failure detection in Radius basically works like that. A user tries to authenticate, the Radius server is being asked the question, and no reply comes back. So that basically means if something breaks along the way, it will only be detected after the first user fell on his nose. Also not exactly the greatest user experience. So what did we try to do? Actually, it is pretty easy what we tried to do on a technical way. You would like to keep Radius as it is with its packet content because it's very much ubiquitously deployed. There is no way around that. But we would not like to transport it over UDP anymore. Instead, using a reliable transport so that you could detect a server is down when the TCP reset comes or the connection times out. Another thing is that we wanted to encrypt the packet content as a whole. And so we decided to add TLS encryption to this. So basically, you get something in a way like an HTTPS connection between Radius servers, if you want it like that. one of the nice things about this is that by using TCP, you get a bit of server state just for free because you know the TCP state. But you can even do a bit more to find out if the server is alive. We had foreseen some application level pinging. There is a status server packet in Radius already that you can send regularly and expect an answer. So even if the TCP timeouts haven't struck yet, you can very easily see that your peer is not there before the first user has asked for an authentication. And using TCP and TLS also made us independent of a very fundamental limitation of Radius. As I said, Radius servers use a static IP address and a static shared secret to communicate with each other. Now that we have a TLS channel for the authentication of the servers among each others, we don't have any need for a very weird and mostly unprotected shared secret, which is based on MD5, by the way. Instead, we have proper TLS encryption. So if we had a mechanism of finding out which server to contact dynamically, we could just contact this server, check if it's actually a right server we want to communicate with, because he's an authorized Eduroam server, and then establish a connection. It is basically possible to eliminate large parts of the proxy hierarchy, because we could not use proxies anymore. We just need some kind of central repository that tells us this realm in Radius is served by this and that server. Something like DNS. We are not quite there with DNS, but we have already seen some profits of using RUDSEC anyway. There is one dash here that says Eduroam at any place. This is something I've been showcasing at numerous occasions so far. Well, the deal so far was you can't just go to some place in a hotel or something and put up an access point and you have Eduroam, because, well, you would need to know the IP address of the place you are, and you would have to phone home to your administrative staff and say, yeah, this IP address is now a valid Radius client for you, so please enable it, and it would be a whole lot of work. Now, you can have an access point that has the DNS name of your Radius or RUDSEC server configured, so you plug it into a network, itself gets network connectivity, establishes a TCP and TLS connection to your RUDSEC server at home, and you can communicate. So that simplifies ad hoc deployments of Eduroam very much, even without the dynamic discovery. The name of the server is still in the access point hard-coded, but wherever you are, you can use it. Actually, I'm delighted to say that one commercial access point vendor has already included RUDSEC for this kind of thing in their production firmware. Well, it's a very small one, so don't jump off your chairs. It's not Cisco. It's a small company called Lancom, based in Germany. They used to be the successors of ELSA, which, was a very big company some time ago. Meanwhile, they just manufacture access points, routers, and all-in-one boxes. But that's actually an advantage, because for about 200 euros, you can get something that has RUDSEC in it and can easily be configured just like that. And yeah, actually I'm very fond of this company, so yeah. Please excuse the sales pitch. So there is one thing some people sometimes have problems understanding, and that's why I want to make it clear here. It looks like there is an inflation of the use of TLS and X509 certificates, and what do all these certificates have to do with each other? So we have had TLS at one spot ever since in Eduroam, and it is not going to change with RUDSEC. It is the certificate you present to the user when he is doing his authentication, EAP TLS, TTLS, or PEEP. This is not going to change. You still have your same CA issuing certificates, the same rolled out supplicants that contact the same server. So it's completely orthogonal of the TLS use in RUDSEC. RUDSEC, on the contrary, is a peer-to-peer connection between Radius servers. Your users will never ever see any of those Eduroam component certificates that we're issuing for RUDSEC servers. It is just something between the admin and his box. That's basically all. Of course, you could think about using the same certificate for both, but since almost everybody has already rolled out CAs and server certificates, I don't imagine that to be such a great idea. But, well, maybe new participants could. But definitely you can keep them separate, and that's what usually happens. So, yeah, what's the catch? All this sounds pretty nice, at least to me. So there must be some kind of problem with it. Well, it's not really a problem, but this is not an IETF standard protocol. IETF had their own ideas about doing a better radius some long time ago. The protocol is called diameter. Unfortunately, it has turned out to be pretty much unusable for our community. Unfortunately, since they have diameter, it also made it improbable that they might pick up the idea in the IETF. And if I'm allowed to quote Josh in last year's TNC again, he said, this is unlikely to gain traction in IETF. And I was sitting in the audience, and I very much agreed with him. I was pretty sure that what we are doing is a nice exercise of writing up an internet draft, but I was kind of expecting to go to the IETF meeting, get the outright no in my face, and go home again. Well, luckily, all of us were wrong. So when I came to the IETF to actually present the ideas, after some very long time of offline discussing with the people involved, the first thing it did was it generated a whole lot of fuss. There were some people who liked it, some people who hated it, but there was not really a clear line. But that is better than an outright no, I thought, in my optimism. So I kept on doing some lobbying work and tried to explain why diameter really isn't the answer and why we need something different. And in the end, the big question was asked just a few weeks or a few months ago about should we really do this RADSEC as a working group item in the IETF? And, 12 people replied. 11 votes were in favor of doing it, which is the rough consensus IETF is looking for. There was one person against it. Well, I know this person personally, meanwhile, after lots of discussions, and even he had said at some point, yeah, it's not such a bad idea, but it's not radius, so I would prefer to have it in a different working group. So that's basically one of the reasons for his no. But anyway, 11 against 1, that's enough for the IETF. And so right now we are preparing to get this really issued as an RFC in the IETF. Well, the process is not so easy. There's a lot to do there. One of the reasons is that we want to do this work in the radius extensions working group because it kind of is an extension to radius. Unfortunately, when this group was formed, it was formed in a way that it should not hamper diameter deployments. So the charter of this working group was very restrictive. It was not allowed to do TCP. What a revolutionary idea. So after agreeing that RADSEC is a good idea, we have first had to initiate the process of changing the charter of this working group. And that happened also just a month ago, probably. And there have been some small changes, but actually they're good changes. The initial idea was to have this one document about RADSEC, and that's it. That's what I basically wrote down in the current version of the draft. But at some point, people said, well, maybe there is a reason to do TCP and not TLS. And some examples where somebody would like to have an SSH port forwarding tunnel and send his packets over that. So the question was, might it be better to have two documents, one documenting radius over TCP and another one using TLS to protect this? And this is actually the way that was taken. There is a new text for the radius charter with these changes, and it is currently in review by the IESG, the Internet Engineering Steering Group, which is kind of the governing, self-appointed governing body for the IETF. Well, some people in the IETF might not like that definition, but never mind. Yeah, and we also have a date to publish these documents. A scheduled date. Let's see if we can keep it, but looks good. Those two RFCs would then be published in March 2009. They will also get not a real standards track status. That was probably asked too much. They will get a status called EXP, which means experimental protocol, which can later be converted to standards track if it proves to be a good thing. But anyway, that is a lot more than I originally hoped for. Okay, apart from RADSEC, one remark that's closely related. We also have other issues in EduRoam, also those that Josh mentioned in his last year's talk. For example, that when your connection to EduRoam doesn't work, it's quite famous that you're just being told no. There is no way to actually tell you what went wrong. Some supplicants are even nice enough to tell you, well, probably your password is wrong, which is probably the most annoying answer you could get if you know that everything's right. So that is also something we want to work on. Well, okay, so where are we with implementations so far? The original implementation that is several years old already is by Radiator, Open System Consultants in Australia. Oh, this is not the most current version of the slide I see because, they used to have no proactive failure detection, but we convinced them that it is really a good idea to do this, especially since our own product, the RADSEC proxy, has it. And so this should actually state it's already in development. So one of the next versions of Radiator would have status server pings and TCP link state detection to find out how the peer is doing. Well, we also have our own RADSEC proxy, which is a very lightweight implementation done by Stig van Aas, and he has really done an excellent job at creating some kind of reference implementation for us. It basically has all the features we want. What we had been neglecting a bit until recently was accounting support, because EduRoam is not so much into the radius accounting business, but even that is in there so far. Then we will very likely have a contract about free radios doing this work, which is basically Anna de Kock doing this work. We are still in the negotiation phase, but this is very likely to take place. Also, we have this Lancome access point. I'm not going into detail anymore about that. And we are constantly looking for more implementations, of course. There will also be a deliverable about our RADSEC implementation so far and how we integrate it into EduRoam. It's going to be out in a month or so, and it has the nice title DS 5.4.1. It's about RADSEC integration. Just stay tuned to see this deliverable as soon as it's finished. Okay, this matrix I will going to skip. It's just about the features that some implementations have, but I'm running out of time, so I'll keep it short. Now the question is, what did we do so far in EduRoam, and what are we going to do? Well, we have already two implementations that are usable right now. That is Radiator and RADSEC proxy. Some NRANs even consider using RADSEC proxy as their top-level server, because the top-level servers in EduRoam do proxying exclusively, and RADSEC proxy is specifically designed to do an excellent job in proxying. So there are several NRANs already replacing it. I run an instance in Luxembourg, for example, and it really shines. Free radius, well, as I said, stay tuned. It's going to come. Then one other thing that some people don't really understand so far is, and that's why I put it here, there is no global choice, I do RADSEC or I do radius. You can integrate both quite easily. All of our RADSEC implementations also can connect normal radius clients. So if you're an NRAN with 50 institutions and 48 stay with radius and 2 want to do RADSEC, you just enable those 2 peers for RADSEC, and that's it. So you can really slowly and smoothly migrate. So the current state, and I'm about to finish. Our both ETLR, which stands for European Top-Level Radius servers, are both enabled for RADSEC meanwhile, so all connected NRANs can connect to them. We have several Federation top-level radius servers, which is NRAN servers, that are already using it in service. When I authenticate via RADSEC. Well, for the institutions, it's a bit more problematic to tell who is doing what, just because we have a federated model, and what institutions do within their NRAN is basically their own thing. Jan Tomasek from the Czech Republic was so nice to tell us on a mailing list that he has already converted 1/3 of his institutions to use RADSEC, which is quite an admirable effort. So we have some significant deployment, and I think there's nothing to stop us from doing more. Okay, so this is just a reference slide where you can look up some stuff about it. If you read the internet draft about RADSEC that I wrote, there is a fair chance that in a few months' time it will be replaced by those two separate documents. But anyway, this describes the current state as we have it. And then there is some software links. And please stay tuned for DS541. Okay, that's about it. Thank you for your time.
Thank you, Stefan. Are there any questions?
Carmelo Zacconi from the Belgian government. So 10 years ago, I used to work for the ITF and working on different working groups like radius, diameters. I was even the buff of the diameter creation. So your project is very, very interesting, but I want just to mention one point. In fact, what you try to achieve here, and which is not there, of course, in radius, it's a kind of mix of what SAML and SIP can provide together if we have a certain glue between them. Because SIP provide all what we need to have all the negotiation, transaction, and so on. SAML might provide everything which is needed for the authentication for security part. Using the transport might be SIP, using the content might be SAML, and then a glue in order to achieve the objective of a AAA or 4A system. So I was wondering why trying to get back something and extending it and not looking right now what are the best stuff available to create something which is really 300% what you want.
Yeah, well, there is one problem when you mention SAML and friends. With Ethereum, we are doing 802.1x on layer 2, and there the choices of what technologies you can deploy are very narrow. And the choices for us is either use radius for credential transport or diameter, for the simple reason that we do this EAP over LAN. And the only way of doing this in any specified way is to have a AAA server like radius or diameter behind it. And yeah, basically our problem with diameter is that this is a very much commercial market with very expensive servers that the educational community just can't afford. And most implementations also focus on the 3G market for SIM card verification. And while what a university would need is plug it into an Active Directory. And this kind of implementation, backend implementation, just doesn't exist.
That's the reason why I thought why SIP architecture with the dynamicity of the establishment and so on, it's not just about voice or video. It might be a security session in order to establish an achievement. So.
Is there another question? If not, then I have one. You just showed us that it's basically possible to have compared radius where you have a strong hierarchical architecture to bypass certain parts of the hierarchy with RADSEC. Would it even be possible to have a full mesh peer-to-peer backend with a technology like that where you don't have a certain hierarchy, we know it from radius or DNS at all? Would that be possible?
In a very distant and ideal future, yes. If everybody is going to do RADSEC and has some kind of lookup mechanism, there could be direct peer-to-peer connection from institution to another. What we have seen so far in reality is that some admins just don't want a direct peer-to-peer connection. They want to have some control over the traffic that enters their country or not, because they have some special needs, like they have secondary pupils that are supposed to authenticate nationally but not internationally, so they can filter out these requests, which is then obsolete when they have direct peer-to-peer connections. So technically, yes, and I will embrace it, but administratively, I wonder if it's going to happen in anytime soon.
Thank you. So let's thank the speaker again. Well, that was the back end of Ethereum. Now we're moving with the next speaker to the front end. The front end as of what does the user need to actually use a service like that? And I would like to welcome here Matthew Gust from the Trapeze network, and he will give you an insight about an open source project concerning an 802.1x client. Matthew, the floor is yours.
Thank you. And I'd like to thank the conference for inviting me. It's been my first trip to Belgium, and I've had a wonderful time. On the screen right now, you see a very rare species. It's Matthew sutus. I'm very glad I don't have to wear a suit. It's one of the things I love about talking to audiences like this, is that I can breathe freely without a necktie. I am perhaps best known for writing the O'Reilly wireless book. It is such a lucrative endeavor that I have the job at Trapeze Networks. You can read about me on the slide. You didn't come here to listen to me talk about myself. You really came to hear about this open source client. So first, I'd like to start off and talk about this organization called the OpenSea Alliance. This is a group of companies that got together to address what we saw as a problem with 802.1x, in that it can be very difficult to use. We all had an interest in making it easier to use and providing better tools. One of the problems that we have at Trapeze as a supplier of large-scale wireless LAN systems is that on the client side, you have a whole plethora of tools, and it would be awfully nice if you could get one that worked on every platform. It's also nice when you can get bugs fixed, too. We met a little over a year ago about a way to address this by starting an open source project. And we found some other companies that were interested. And we got together this group. We called it the OpenSea Alliance. C is really a backronym. It stands for Secure Edge Access. We hope to move beyond supplicants at some point. But that's a bit in the future. Our first project is to create an open source supplicant that is widely used and works on many platforms. And part of the reason we did this is that there were companies that had an interest in this, but we all had a small interest. And by putting it all together, we could come up with a group that could really make an open source project happen by taking contributions and resources from a wider group. It didn't have to be just one company that had this interest and put it all together. So you see the founders there on the screen. We were lucky in that when we talked to Janet in the UK, they had seen the same need. Open source works much better when you have the user perspective, so we've been very fortunate to have their participation. The Alliance launched last year in May. At the end of the year, we did get some additional members. And just as a note, when I talk here today, I'll be perfectly honest in that I do work for Trapeze Networks, but I'm doing my best to represent this open source organization instead. So where are we now? The first thing that we did at the OpenSea Alliance was we put together, or we adopted the Open1X project. The project has a website because we don't all live in the same place and we have to communicate electronically. As I said before, what we were trying to do was come up with an open source 802.1x supplicant that worked on multiple platforms. If you take a look at how the software is constructed, and there's a slide that shows the interrelationships a little bit better later on, we took the X supplicant project, which had a very robust engine, but it meant that in order to configure that robust engine, your tool would be something like VI or Emacs, which is, well, I'll be honest, I have trouble using VI. And if people like me have trouble, it means it's impossible for end users. So the first thing we did is we put a GUI on it so that a normal mortal person could do this. And then part of what we were trying to do is come up with a way to make this extensible. We've seen 802.1x really grow up in the last 5 years. There are functions that now were not imagined when it was put together as a standard. Things like admission control, like we heard about yesterday morning. And there are often different ways of doing things. So rather than build the code into the engine, there's a plug-in architecture that allows you to write a piece of code for a specific add-in function and then plug that into the core engine so it doesn't have to be part of it. The project is run by a group of people who have expertise in this area. It's chaired by a guy named Chris Hessing, who started the Open1X project, and he chose several people who are well known in the industry to lend their expertise. So thankfully he picked me. If you're watching this, Chris, thank you. Then as a nice little tie to Stefan's presentation, Mike McCauley, who wrote Radiator, is also a member of the team, and as is Josh Howlett. This is a block diagram of how the supplicant works. At the bottom, you have the network interface. So this is something that you get on every operating system. It looks a little bit different. And then I've put 3 boxes on here because we really think about this in terms of having 3 components. So the lowest box is this core engine, which is distributed under GPL and BSD licenses. So there is a layer of code that allows you to interact in a standard way with any operating system. Our initial platform targets are running on Mac OS, Linux, and Windows. And it's kind of interesting how different some of the Windows platforms are from each other. I'll just leave it at that. Then there is this core engine functionality. EAT methods plug into that. That's the .1x protocol driver and the sort of housekeeping functions that you normally have. On the upper left, you see the plugins. The 2 plugins that are best known at this point is there's a plugin that does crash reporting. One of the hardest problems you have with running code on the client side is if it doesn't work, you will have to get an error report. Well, why not just automate that, have a button that says, I would like to send off a debug log and all the state information. Turns out that the person who wrote that was smart enough to realize that he should actually get the entire debug log, not what's printed out by the supplicant. So the crash reporting code actually can give you more detail than a user can because it has access to all of that information. The other plugin that's widely used at this point is that libTNC, an open source implementation of the TNC protocol stack, can be linked in as a plugin. Admission control, because there are so many frameworks, we expect that will be an area of active development for this plugin architecture. Then, on the upper right, you see the graphical user interface. That was one of the biggest things that came out of starting this project, is that now there is a UI. There is the control between the UI and the supplicant engine itself is done over an interprocess communication channel. That allows you, actually, if you were so inclined, to write your own GUI because that channel is documented. It's also handy if you were to look at doing things like running on, say, a smaller platform that you don't typically think of as having the full graphics support you would on a laptop. Here's a couple of screenshots of the GUI. These are off Windows, but the GUI is written using Qt Designer. The reason for selecting that is that it is a cross-platform GUI designer, and that allows you to get the GUI running on every platform. So it looks like this on Linux. It looks like this on Mac OS. That's been something that's been very important at some of the test sites, as many IT administrators at universities have said to me, we have no control over what students bring in. And then often they scare me by talking about things like Windows 95 and Windows 98, even at this point in time. In addition to control, you also get a reporting channel, which allows you to display the status window that you see at the lower left-hand side. That's a summary. You can actually get all kinds of information. Basically, anything that gets pulled out of the driver, you can place on that status screen. That also allows you, if you were so inclined, to extend the status screen. The GUI is also integrated with the plugin architecture. So a plugin can also create components in the GUI. If you had a TNC plugin, you could use that plugin to add in configuration for it in the GUI as well. So here's a screenshot of Qt Designer. One thought that we had was that perhaps somebody would be interested in making an Eduroam or Ren skin. So that's very easy to do. It's like I said, it's standard Qt Designer, so it's pretty much open to anybody, and that's been of interest as well to some of the corporate members who are interested in using this as a base to build their own products on, because they're able to reskin and have options that are specific to their own configurations as well. So this is all fine and good. What are we doing? So the first thing is that we do have a roadmap. This is maintained by that project management committee. We codename each of our releases. It just is kind of a fun little fact. All of our releases start with the word C because we're the Open C Alliance, and then we use animals in alphabetical order. So the first release is C ant. The second release will be C badger. I'm waiting to get to CN for C narwhal. I actually wanted to codename the first release narwhal, but it does make more sense this way when you can easily tell what codename comes in what order. You can download the current roadmap. As an open source project, we try and make sure that everything we have to offer is easily available. The roadmap gets maintained by this committee, but we get requests from all sorts of places. One classic open source way of getting requests is on the mailing list. So feel free to send us mail. We don't get enough. There is a wiki for the project. You can go ahead and edit that page. It should be open to everybody. If it's not, let me know. Since I run it, it means I've set it up wrong. And then we get requests from users as well. It's one of the reasons why I like coming to conferences like this, is because I always get told what I should be doing as opposed to what I think I should be doing. And the two I try and keep in sync, but there's a lot of value in coming here for that reason. Some of the engineers on the project are employed by our members. And one of the nice things about this is that they do get time to work on the open source side of the roadmap as well, which I think is something that they should be commended for. We do try and update the plan every major release, and we set the plan for the next release. So there's a fairly late binding. That means that suggestions have a reasonably good chance of being considered for the next release if they are important. So as an example of this, we got a request to do opportunistic key caching for fast roaming, and it was at the right point in the release cycle to be added, and so we were able to do that very quickly. In the next release, the CANT release, to be brutally honest, the current release floating out there runs best on Windows for reasons I won't go into. So our big task is to bring the Mac OS and the Linux releases back up to par. And then we're looking at the freight train that is Vista, and it is bearing down on us, so we're trying to squeeze that in as well. In the engine itself, we're doing a fair bit of work on EAP methods. So the Cisco PEEP method that is out there, it's part of the Wi-Fi Alliance testbed, that has gone in. There is some modification to the EAP GTC code to support that, as well as EAP fast. And we're adding some TLS configuration. So one of the things that does happen sometimes is with this project is that it's possible to get a feature in the engine that you can configure by editing an XML file before you get that capability in the GUI. So the TLS configuration is going into the GUI to make that easier. And then, as I mentioned a couple of minutes ago, opportunistic key caching, sometimes called proactive key caching, that allows you to move between access points much quicker. That's important to us just because there are some requirements out there for fast roaming, especially in embedded platforms. So we're kind of looking ahead to that. It works very nicely if you have certain types of wireless network architectures because it allows you to really move between APs with just a few messages, and you can cut out the whole .1x handshake. Sadly, we have a lot of documentation work to do. We're behind on it, in large part because it's much more fun for me to do things like come here to Belgium than it is to write documentation. Within the project, there's a bunch of infrastructure work we're trying to do. So we have to upgrade a bunch of libraries that we use. We need new features in some of them. Sometimes it makes it build easier to have current versions. We have set up an automatic build environment for Windows. You can get nightly builds. Warning, if they break, you can use both pieces. Then we're working on making sure that that's packaged up so that you can run the nightly builds if you want, although I really would only recommend it if you expect that there's a fix you need in there. Then we're doing automated QA work to automatically test these builds and improve debugging tools as well. So if there's anybody out there in the audience who would like to participate in this, we'd love to hear from you. So if that was what we're doing for the future, what are we doing in the more distant future? So how can you help? Because honestly, we'd love to have help. The easiest way, or the most straightforward way, is that it's an open source project. If you want to work on code, the code is all out there. It's in Subversion. So go ahead and pick up a feature that's interesting to you. Or even better, write code for features that you need. Our criteria for taking code are essentially that the code works. So if somebody were to present code that solved a problem and did not result in instability, we would go ahead and put that code in. So we've had some discussions about putting in some single sign-on binding features. There is an engineer who's interested in a NetBSD port, both of which are things that we didn't envision, but have come to us from the user community, and that makes them interesting to think about, and maybe we can find ways to generalize them. If you want to look at the roadmap and all the development tasks, there's a whole big chart at the URL. But what if you can't code? And, well, quite honestly, I fall into this category. So on the development side, one of the things we're doing to accelerate what we're doing is we're taking some of the membership dues from our corporate members and we're using them to outsource development work. Well, that only works if you have a specification. And you can write a specification without writing code. So that would be one way to help. If you wanted to help us out with where we're going, you can read the roadmap and give us comments. You can suggest things to be put on it. Again, if you can specify them, that's an even bigger help. One of the classic ways to help an open source project if you're not doing development work is to do testing, because the more testers you have, the more bugs you have, and the more stable the code is. So run the supplicant and provide feedback. Or if you have the capability to look at automatic testing, we would absolutely love to hear from you on that. Basically, just reporting what works and what doesn't work is a huge benefit to us. There are often weird configuration things that we find, and the best way to shake those out, especially given some of the wireless driver architectures on various operating systems, is to have access to as many platforms as we can over as big a range as we can. And that's one way that users have helped us out a lot and probably will continue to do so. If you like writing documentation, didn't expect anybody would, you can help us out with that as well. If you're inclined, you can also join our mailing lists, answer questions from users, and join the community that way. So, what are we hoping to do in the more distant future? In addition to all of this near-term work, one of our big initiatives is we really like to think of ourselves as developing a multi-platform supplicant. And right now, that really the initial work is on laptops and laptop operating systems. But going out even further, I was having a chat with somebody once about the amount of CPU power that my phone has and comparing it to the first laptop I had, and my phone wins. There's a lot going on with dual-mode phones and having wireless LANs built into them. You look at the excitement we have around phones that are not owned by the manufacturer but give you some capability to customize them. So the iPhone is the most famous, but you look as well at things like the OpenMoko project, which is a phone that runs Linux and is completely under the control of its owner. This is a huge new area that wireless networking is moving into. And we would like to participate in this by porting our supplicant onto platforms like this. There's a lot to do with standards support in the future. So I touched briefly on putting NAC functionality in. That will probably be through the plugin architecture as long as there are multiple standards. That allows you to just plug and unplug which code you run. So that allows a single core supplicant code base to interact with all of the different NAC frameworks that are out there. Then I do participate in the IEEE meetings looking at .11 standards, and that body has not stood still itself. So there's a whole new set of wireless security standards. So there's 802.11r, which is a fast roaming standard. The other item that's of interest is 802.11w, which is a standard that protects management frames. Interestingly, in .11, there is no protection on the frame that says, get off my network. 802.11w is adding that, as well as some protection for a number of other management-related tasks, which is very important. And then even if you look at some of the stuff going on in 802.11v, Stefan had mentioned doing 802.1x diagnostics, and there's some functionality being built for that as well. And then finally, we're looking at how can we make this into a tool that you can use on a widespread basis. So how can you provide support for centralized configurations and for larger deployments? So I'd like to thank you all for listening. At the bottom of that slide, you see the website for the project as well as the locations of the mailing lists. Then you also see my address. I don't get enough email, so feel free to send me more. And if anybody has any questions, fire away.
Thank you, Matthew. So, do we have any questions?
Philippe Ancet, University of Tennessee. Matthew, one of the problems with the 1X that we encounter is the fact that it's layer 2. So if it's not built in the operating system, there's a catch-22 issue. We cannot distribute the client when people join the first time. So when you have 6,000 students to register, there's an issue. Are you considering that as well in your development?
So I would love to get to the point where we could consider that in the development that we're doing. It can often be something that is difficult. The best thing that we can do right now is that we've worked closely with a company called CloudPath, which provides support for automatically installing and configuring supplicants, and they've developed a way of doing vendor-independent configurations of .1x clients, which you can redirect a captive portal to and then install and configure a client from. That's something we'd like to get to at some point in the OpenSea Alliance, but we have a lot of work just getting the supplicant up to snuff first.
Given the growing support for 802.1x and better written supplicants in the latest versions of the Windows operating system and Mac OS, where do you see the value of an additional client on top of the provided supplicants?
One of the big problems that I've seen in talking to customers at Trapeze and as well as at many events like this is that there are built-in supplicants, but they're all different. So this is one platform for wireless authentication across everything. And the diversity of platforms only looks set to increase moving forward. But it's also a matter of getting things fixed when you do find problems. I would like to think that we would have to screw up immensely before we were as bad as a big faceless corporation at fixing the problems we have.
We have room for one more.
Carmelo Zacconi, Belgian government. So taking into account that the software is open source and that, in a certain sense, everybody can develop some extra stuff within it, if there might be interesting project developing new interesting features for .1x and using the software to implement them, so is the OpenSea Alliance capable of getting back to the IEEE in order to, for instance, push those new extra features in order that, for instance, product vendors who do implement .1x, of course with the standard will be IEEE, such as Trapeze Network, implement it. So do you have a certain power that thanks to your product, people do develop extra features and then get back to standardize them?
So yes, I participate in a lot of standards organizations myself. One of the things going on in the Wi-Fi Alliance right now is that we're revising the WPA certification. And part of that process is developing a new test bed. And that really helps drive adoption by product vendors because once you know what's in the test bed, then those are very interesting features to implement to pass the certification tests. So we will be putting that together later this summer for the revision of the WPA testbed. I certainly hope that the Open1X project is configured for that. And then as far as the second part of your question about how much can we feed into standards organizations, a lot of what I do does come from talking to users, whether it's through a forum like this, whether it's through interaction in an open source project, or meeting somebody at an organization like the IETF. One of the things that the industry has to do a good job of is making sure that we're building products that people want. And for me, this is just another source of information on what we should be building as a product vendor.
I mentioned that because the Belgian Ministry of Equipment and Transport has a concrete project which needs some extensions and might be useful.
Well, thank you for letting me know. I would love to talk to you about that offline.
There's the last question, please.
Not so much a question as an additional remark. Klaas Wieriga, Cisco. I think one of the other advantages of having a supplicant under your control is that it's much easier to integrate it with all kinds of other cool things you would like to do, like setting up a VPN connection, like adding SAML assertions and to get a universal single sign-on across applications, all these kind of things that are typically completely closed when you use the built-in supplicant in the operating system.
Good. Well,
Thank
Matthew, thank you. Well, this then leads us to the third speaker of this session, which is not according to the program Ruizu. It's Lino Santos. Ruizu had cancelled his attendance at the conference due to family matters, and I would like to welcome Lino Santos and thank him right up front for filling up the gap. Lino Santos works for the FCCN since 1995. He was mainly involved into network security, mobile, as well as multimedia. And his talk will be about basically what we have heard now from the back end and the front end, how you glue them together and how you scale it and bring it out to the user. Go ahead.
Thank you, Hans. And I'd like to thank also to the Commit program for this invitation and the opportunity to share with you and, of course, get your comment on this deployment issue of EduRoam. EduRoam in Portugal has a different name. It's EU, Electronic University, is a government initiative that has a lot of objectives that I will show to you. And one of them is to implement wireless networks in higher education institutes. And for that part in particular, we adopted EduRoam as a solution. The agenda for the presentation, I will start to explain a little bit about the concept and strategy of EU initiative in Portugal. I will tell you that and how roaming was set from the first beginning as a key goal for this initiative. Then I will describe in detail the deployment with the project timeline, achievements, and of course constraints that we found. And I will end up with some statistical information on, I think, five years of deployment. This is the overall concept. It's not only wireless networks. It's wireless networks at the campus. It includes broadband access at home for students and teachers. It includes easy of access to laptops at cheaper prices than the market. It includes the dematerialization of services at universities, the webization of these services. It includes e-learning platforms for these universities. It includes access to contents, to online contents. And of course, on top of this are the user and the user needs. EU initiative wanted from the beginning to have a broader impact on Portuguese society. It was identified as a driver to achieve the families, the students' families, from teachers and from students to their own family and to their houses. The policy objectives of this initiative was to disseminate wireless networks on every higher education institute, either public or private, to boost online academic contents and services, as I said, and to promote better ICT market prices for the academic community. I think a singularity of the Portuguese EduRoam deployment is that it was centrally funded. It has public investment of 30 million euros. Every university applied for this funding with a project. The project had to include all those stages I mentioned in the first slide. And of course, to do this, we had to involve ICT vendors and banks and other partners to achieve this. Also, we planned from the very first beginning to make an aggressive marketing campaign to get to the users. This is a short list of some academic service and administrative service that every institution was obliged in their application to provide and to implement in their own institution. Of course, the higher education institutes were in a wider stage of deployment of all this. Some of them didn't have anything on the web. Some of them have already some services implemented. This is just a short list. The whole list is about 38 services, including e-learning and academic services. From the strategy, we had to implement and involve major ICT suppliers. This is just an example, laptop vendors, ISPs, banks that provided cheap money to buy these laptops and the broadband access at home. Some others like Microsoft, Sun, Intel invested a lot in this project, and of course Wi-Fi vendors. We are also at this stage making partnership with other Wi-Fi hotspots suppliers. Expresso is a major media service in Portugal, which has an online paid service, and they are willing to give this service for free for students. And Optimus is another Wi-Fi solution. Of course, from the very beginning, the roaming was set as a major goal. We set as an objective for the wireless infrastructure to have total mobility between all institutions involved through EU roaming system. And at the same time, we realized that the same initiative was going on in Europe, and we joined TF Mobility in 2003. Very quickly, because you've already seen this a lot, the roaming solution that we adopted was .1x. For instance, if I present myself at this university.pt, I tried to connect to the .1x enabled hotspot. Then the secure tunnel is made to my home institution radio server. Then I give my credentials to this home institution radio server. The local radio server gives me okay or not okay, and then I'm connected in a secured way to the hotspot. Now, a brief of the timeline deployment. There was this public announcement of the EU initiative in January 2003. By this time, we were already setting up 8 trial configurations in the equal number of higher institutions, what we call the study for a national roaming solution. We tried .1x, we tried web-based authentication, and we tried also a solution based on the certificate hierarchy signature. In June 2003, EU joins European top-level radios hierarchy. I think we were the third, right after the Netherlands and the UK. Right, class? Yeah, thank you. In August 2003, we already finished the trial projects, and we set up the requisites for the infrastructure hotspot, and we started to build a vendor test bed. The objective was to, we have these requisites, every hotspot has to achieve these requisites, but what solutions are in the market? We have to test them, and we have to certify them. So we built up a vendor test bed for this. In October, we published the National Roaming Solution. And in November, we published the first vendor cookbook. This was not a problem, but a constraint. We only had, until November 2003, one vendor that was able to do all the requisites. And we had to wait a lot to get more vendors to do what we wanted. That was dynamic VLAN assignment, .1x, and this was the major, and this was the problem, to get dynamic VLAN assignment. Oh, yeah. In November 2003, all the universities applied to funding, and the contracts were signed. In June 2004, we had the first hotspot certified. Of course, for the founding institution, they applied us, FCCN, was responsible for this mobility solution, to verify each institution that was really doing what they applied the fund for. So we had the first hotspot certified in June 2004. Then we had to build a service, a mobility service, and for half a year, I think, we were dialoguing with all institutions, and we set up a document named Terms and Conditions for EU Mobility Service that set up the obligations for users using the mobility service, the obligations for home institutions, for visited institutions, and for the NRN. We also had, and this was a major discussion, to define in a technical way what is internet access, because a roaming user was declared to have internet access, but as there was this different interpretations of internet access, we had to put it on contract. We also put in this document the way that the user can have support and the way that the user can, the way that the institution can complain about users' misusage. From June, the technical conditions of the service was based on web, and the SSID was EU. So, for better integration with Heteroam initiative, we had to step forward. And from June to December 2007, we made a change in the whole infrastructure, in every hotspot, in every access point, to change the SSID from EU to Heteroam. And we also changed the encryption system from web to WPA. Now some statistics. 55 higher education institutions integrate the project, representing 92% of the Portuguese academic community. 51 of those have already their wireless network available and certified, reaching 307,000 students. And by the end of 2008, all EU institutions will have the content and services available. Personally, I don't believe this. If they didn't implement yet, I don't think they will do it. Some more statistics. The percentage of Heteroam users from total amount of students for these 6 sample universities from July 2006 to April 2007. This means that from the beginning of this project, 50% of the users of that institution connected at least once to a hotspot, not in roaming, to a hotspot. Talking about roaming, this is the growth of the roaming usage, and this was even for me good news. There was many people that were asking what roaming is needed for. Did people actually travel a lot between institutions? And I think this graphic shows that they do. We have a lot of people, 5,000, 8,000 people in 1 month actually connecting to another institution that not their home institution. Now the overall usage, this is not only roaming is in blue, but also local usage in green, and we have about 60,000 maximum usage and growing as you see. Now this are some sentences made by partners. And I think that's all. Thank you. Questions?
So thanks for that interesting presentations. Do we have any questions?
Yes, Stefan Winter. It is very impressive that you have changed the SSID and the encryption scheme within 6 months in the entire country. That is very expensive because we have several other elements that also have various SSIDs or other encryption schemes. So my basic question would be, how did you make this happen?
Actually, the calendar we gave the institutions was not 6 months. It was 2 weeks. But I explained. we set up a document, and we told them to. Of course, they were convinced by some presentations from class, for instance, from Diego Lopez that were made for all the institutions, and everyone agreed informally to do it. That was the first step. Then we had to prepare this migration, and the way we tried to use it to do it was to each institution to notice the users before the change in an advantage, so in an advance time. So that's why the 6 month. The change was programmed for December. Then whenever we tried also to have similarity of usage, the EU SSID and the EduRoam, but that was only possible with 3Com access points. Other vendors couldn't do it in conjunction with dynamic V-line assignment and different encryption methods per SSID. So the only one that actually do it was 3Com. We tried that. So we had to go to chaos, and okay, everyone changed in these 15 days. But of course, we prepared for a long time the communication with the users and prepared the support to be able to work hard in these 15 days.
There's one more question.
How important do you think it was to the success of the EduRoam rollout to have it as part of the greater EU project?
That's a good question. I think it was at the same scale as the other layers. For instance, almost every institution at this stage e-learning platforms that didn't have at that stage, and that's a huge achievement as well. The bigger universities are making some revolutions inside, teaching the teachers to put contents in the e-learning platforms. So it's at the same stage as the others. I think the things that went less good was the partnership with the laptop vendors. For instance, we tried to have a web page with the prices of each vendor, stating that it was 10-20% less that you can find in the market, but that's impossible in the market of laptops. Every day was changing, and so there was, I think at some stage there was no confidence, and that actually the EU offer of good prices was actually better prices. I think that didn't went so well.
Okay, I also have a question. First of all, congratulations on what you have achieved. I'm very impressed. And then what rises in me is, what next? Have you any plans on extending the geographical border from campus also further out to, for example, private homes? That means that people that run an access point within their flat or house, that they also could connect via the EduRoam to your network?
Well, I think the next step, the obvious next step, would be to get to the other schools, the elementary and secondary schools in Portugal. We'll see if that will follow that path. This is also another thing that we wanted to do is to make a peer with other Wi-Fi ISPs. So that's something that we could work on making peering them, providing the users to access at cheap prices in lots of hotspots in Portugal. And I don't know more. Okay. That we can go ahead.
Okay, we have one more question.
Short one. I can't check it at the moment because my network is lost. But do you have any means for your users to check when they are traveling to some other place? What are the conditions in the place they are going to? So any map-based presentation of services they can expect there?
Yeah, that's all in the second link over there. Thank you to remind me. At www.edurom.pt, you have a list of all the hotspots that are available and the conditions.
Okay, then, Lino, thanks again. This then brings us to the end of this session. I hope you have enjoyed the content. Once more, thanks a lot to all the speakers. It was 3 very interesting presentations, and that leaves you more time for the coffee break, so enjoy. to